Hello everyone. I miss seeing you. I wanted to go over a few things with you about what we're doing with this unit, which is, as you know, about the properties of gases, and to clarify some expectations for you. One of the things I want to let you know is I know that not everyone is actually signing in for their attendance every day, because last week on the absent list, some of your names were on there, and I know that I was getting work from some of you. So if you're looking at your email and going directly to Edpuzzle or to some other activity that's attached, make sure that you do the login part for the attendance every morning. That's super important because that's how they're keeping track of your attendance. Also, I did ask that everybody go to Teams, and I saw some of you there, but I don't know about some of you. So my goal is that if I can get you all on Teams, and I think a lot of you are already there, I'm going to start putting the assignments there so that everything's in one place. I think it's a great place for us to be able to communicate, and so that's the goal. So I want to go over a few of these things about the gases with you, and then give you some tips about the graphs that you're doing for your work today. So I don't want to waste any more time. Let's get to it. I have prepared a note sheet that's attached to the email, so you don't have to write a lot of this down. You can just go to that note sheet. It'll already be there for you. But what you looked at last week was called the kinetic molecular theory of gases, which is a theory about how gas particles behave and do things. I'm not going to read all of these points to you. You can stop and start this video at your own leisure. But the ideas there are that gas particles are always moving. They're colliding with each other and the walls of their container. That's where they get the pressure. They make a pressure from these collisions. And if you've ever been in the wind, you know that that's possibly a lot of pressure. When we look at what gases are like, they're fluid so that they flow. They mix easily like liquids do. They will fill up their container, just like we talked about when we went through the 3 states of matter. Okay. Gases will take both the shape and the volume of their container. They're highly compressible. You know that from just squishing at a balloon. They have mass. Of course they have mass because there's molecules and atoms there, but not a lot because those molecules are so far apart from each other that we know that a balloon is pretty light because there's a lot of space in between those particles. If you bring flowers into a room, the molecules of the scent from those flowers will start out near the flowers and then slowly, not terribly slowly, begin to diffuse throughout the room. That is that process called diffusion. One of the things that you want to understand is that it really doesn't matter what gas it is. The way that gases behave is consistent for all of them. And so whether it's nitrogen or carbon dioxide or air, which is a mixture of different gases, they all behave pretty well the same. So when we talk about the kinetic molecular theory, it doesn't matter what the gas is, it's describing all of them. What do we actually measure when we study gases in the laboratory? We can measure the pressure exerted by a gas, the volume, which is of course going to be the volume of the container, the temperature. We always use the temperature scale of Kelvin, and if you recall, we had talked about temperature scales early in the year. We'll touch on that again. We can look at the mass of the gas. We would have to, of course, get the mass of the container if it was in a big tank, and we would subtract out the mass of the container. That's how they measure when they refill the gas the gas containers for your gas grill in the summer. You take the tank in, and then they fill that. They put that onto a scale, and they actually zero that out, and they add the gas until it's the number of pounds of gas that you're buying. And so they do measure the mass of a gas. It's a little bit trickier than just getting the mass of an object like a piece of copper or steel, but it is done, definitely. We can also count the number of atoms and molecules, and atoms and molecules are grouped into this group called the mole, which has a whole lot of molecules or atoms in it, 6.02 times 10 to the 23rd. That's a really big number. So yeah, we can talk about how many particles are there as well. That's not something we're going to be doing right away, but it's also part of the things that we can measure when we talk about a gas. For our purposes, we're basically measuring three things, and we're going to be looking at three measurements: the volume, the temperature, and the pressure of a gas. And so how do they measure the volume? If the container is something and you know what the volume of the container is, that gas fills the container, there's your volume. If not, we would do what we did back last fall when we talked about density. We figure out the volume by water displacement. Here in the picture, you can see that they're pushing the balloon under the water and seeing how far up the water goes, and that's how they're going to measure the volume. Some tanks are set up so that you fill the tank up all the way to a side spout, and then when you add that object in, when that object goes into the water, then that water displaces up and comes out the side spout, and then you can measure that into a graduated cylinder or some kind of a volumetric piece of equipment for measuring volume, and you'll have the volume of that object there. Of course, we use thermometers for temperature, and we have our Kelvin and our Celsius temperature scales that we'll talk about during the gas unit. We really won't even go back and talk about Fahrenheit. And if you remember, the Kelvin scale is the Celsius scale plus 273, and then the if we have Kelvin, we subtract the 273 to get back to the Celsius, and that'll come up again. But basically, we use a thermometer for measuring temperature, and we measure pressure, as you learned last week, with a barometer, the atmospheric pressure, and we use different kinds of equipment, manometers and pressure gauges. A tire gauge is basically measuring the pressure of that air in your tire. Last week you heard the video presentations talk about atmospheric pressure, and one of the things I want you to be aware of is this thing called STP, which is standard temperature and pressure. And a lot of times when we study gases, we talk about how they behave under standard conditions, which means that the temperature is going to be 0 degrees Celsius, which is 273 Kelvin, and then the pressure is at 1 atmosphere, which, if you remember, 1 atmosphere is the same as oh, I'm doing that wrong, sorry. It's the same as 760 torr. My stylus isn't too cool here. And then we can do the conversions on that, but we call that standard temperature and pressure. So when you hear that, you'll know what that is. Here's those pressure conversions that we talked about before, and there's a couple extras there that we won't really be using. You can stop and refresh on how to do these conversions at this point. When we talk about measuring pressure, you saw about the barometer, And barometers look a lot of different ways, but this drawing is your basic idea of a barometer with the air pressure, the pressure from the atmosphere around us pushing on the liquid mercury, which is that silvery liquid metal that I'm sure you've seen, if not in real life, in movies. It used to be the thermometers had mercury in them, but not so much anymore. A manometer is a piece of equipment that'll measure the pressure of a gas inside of a container. This is what a barometer looks like on the wall, and you measure the millimeters of mercury. This part in the middle here is the mercury column coming up, and that's actually going to have a scale behind it that looks like a ruler, and you literally measure the millimeters of the mercury. That's why we have that pressure unit, millimeters of mercury. And then modern barometers have a gauge type, and you can see the dial. It's more of a dial gauge. They've changed those over the years. An open manometer is in what I would call an old-fashioned way to look at the pressure of a gas in a container. And basically what it does is it has a U-shaped tube with the mercury in it, and what happens then is if the gas inside this container has a higher pressure than the atmospheric pressure, then the gas is going to be pushing on this mercury column, and it will push that mercury up, and you'll see a higher column on the side closer to the atmosphere. But if the gas inside the container is got a lower pressure than the atmospheric pressure, this section here is open to the atmosphere, so the atmospheric pressure molecules are going to push that mercury, and then you'll see a higher column on this side closer to the contained gas. And that's how traditionally, a long time ago, you would see a manometer be used on tanks or glassware here shown with gas in it. And then, of course, modernized, what we have now is we have a dial pressure gauge, and we have our tire pressure gauges as well, different kinds of equipment to measure pressure. Scientists are very interested in how these three factors affect each other, and that's what we're really going to be focusing in on. How does the pressure and the temperature and the volume of gases affect each other? And that's what you're going to be looking into in your assignment, which is some graphing assignment for today, and then we'll continue to talk about these relationships as we go throughout the week. You have 2 graphs to do, and I understand that not everybody has a printer at home, so I don't want you to stress about it. The graphs are kind of simplified. I want you to notice that on the x-axis there's 2, 4, 6, 8, 10, 12. There's 12 spaces there, and that would be 13 lines. So you could literally, you've got 15 horizontal lines. You could use notebook paper, take 15 lines, and then draw 13 horizontal lines that are pretty even. Do it as neat as you can. If you want to do the graph on notebook paper to take a picture of it to send it to me, that is okay. I don't want you stressing because you don't have a printer that's working right now. That's not something that you need to stress about. But you've got your 2 graphs. One is going to be the relationship between pressure and volume. The directions, read directions. You're going to put the pressure on the x-axis and the volume on the y-axis. Do you remember which is which? And then plot your points x, y, x, y. Your second graph is going to be the relationship between temperature and volume. Again, there's very clear directions. Read them. The temperature is going to go on the x-axis, and then the volume is going to go on the y-axis. And again, you can do this on notebook paper and just take a picture and send it to me. There's going to be 2 questions at the bottom there of the graphs on your worksheets, and we want to make sure that we can talk about what the relationship is, because that's why we're graphing. So when you see a graph like this, if the slope is constant, then you can see that there is no relationship between x and y. The variables are not related, because as x increases, y didn't change at all. That would be no relationship. But if, as the x variable increases, the y also increases, we call that a direct proportion. And then we call the opposite an indirect proportion, INDIRECT, or an inverse proportion. As the x increases, the y value is going to decrease. So you're going to be asked what kind of a relationship you get there. Understand that on one of your graphs, you're not going to have a straight line. You're going to have something that's more like a curve. So if it was a direct proportion, you'd see a curve. And if it was an indirect proportion, you'd see some kind of a curve that would curve down this way. So one of your graphs is going to give you a straight line, and one of your graphs is going to give you a curve. That's really all I have to go over with you. You should find notes about this attached to both the email, and then I'm going to get some of those things in to Teams. So hopefully most of you have been there. Let me know if you're having any kind of issues with that. I have so far also attached everything to the regular website, so that students who are used to just going there to get things, that's fine. I'll keep doing that if that's what helps you. Please continue to get with me and give me some feedback on Remind about how you're doing and what I can do to help you. Miss everybody. Take care. Have a happy week.